Relative max and min is when we find all of our zeros and then we're able to find points in the middle instead of just making loops that go to nowhere. So in terms of where you want to start with this, let's maybe start with our end behavior of this because we know that for sure. So because it's x to the third, it's positive x to the third, we know it's going to end positive. And because it's odd, odds do the opposite. When odds do the opposite, it means it's going to start negative. So kind of a rough sketch of what that looks like would be something like that. So we know that it's going to turn twice. So we're going to be able to find those points in the middle of that. So now we need to go over to our equation and actually factor that. The first thing I see is that all of these have an x in common. So when I take that x out, I know that one of my roots is going to be 0. Okay, because of that x. So I can go ahead and put that on my graph if I want to. So then I need to factor this. So this is the short method of factoring. You would say, all right, what multiplies to -5 that adds to -4? So what's going to do that is -5 and +1. So this is short method, so it's going to be the x brought down from our greatest common factor, x minus 5, and x plus 1. So then to solve for your other roots, you need to set your parentheses equal to 0 and solve those. So you would get +5 and -1. So 1, 2, 3, 4, 5 is here, and -1 is right there. So we know the end behavior of this, so we can go ahead and graph that. We know it's going to end up, and we know it's going to start down. We just have to figure out what's going to happen in between there. So you can hear the thunder. You can see that we're going to swoop up in between these 2 points. So our relative max is going to be between -1 and 0. So you're looking for what's directly between -1 and 0. So you would do -1 plus 0 and divide it by 2. Well, that's going to give you -0.5. Okay, so you're going to a half a box. So then you're going to plug that in. Just so you know how to plug that in, you need to make sure and put it in parentheses. -0.5 cubed minus 4 times -0.5 squared minus 5 times -0.5. Okay, and that's going to give you a y value of 1.37. And you could round that up to 1.4 if you wanted. Sometimes it's easier to think about this as an ordered pair. So -0.5 and 1.37. So you know you're going to start at the origin. And you're going to go back a half a box and up 1.37. Okay, so that will be your first one. So then my minimum is going to be between the next 2 points, which is 0 and 5. So what's directly in between 0 and 5? 2.5. You're going to plug that into the equation, and you're going to get that y is -21.9. So that's the ordered pair 2.5, -21.9. So that's going to be way, way, way down here. You're going to go over 2.5 boxes and way down. Okay, so then the last thing is you might want to just clean up your graph because the blue part doesn't look quite right. So you might want to fix that and make it just one really, really smooth graph. Okay, so let's go through one more of those. Same thing here. Start with your end and start behavior just so you kind of know your starting points. This is raised to the fourth, so they're going to do the same thing. And it's positive x to the fourth, so it's going to be up and up. So it's going to look something like a W. All right, so we want to factor this. And we know how to factor this. X to the fourth is still something we can factor. It has to multiply to 9 and add to -10. So what's going to do that is -9 and -1. So this is short method because our a value is 1. Just remember that it's going to be x squared minus 9 and x squared minus 1. You have two options here. You can either factor these down again because they're difference of perfect squares, or you can use the square root property, which is probably what I would suggest, and solve it. So then I would move 9 to the other side. Then I would take the square root of that, which is going to give you 3 and -3. And on this one, same thing. 1, move your 1 to the other side, take the square root, and that's going to give you 1 and -1. So your roots are going to be at 3, 1, -1, and -3. So I can go ahead and graph my end behavior. I know it's going to be up on both ends of that. So now you're looking for your maximum and minimum. This one's a little bit tricky because there's two minimums, but let's talk about that. So you're going to go in between these two. The first two to begin with, that's going to be a minimum that goes down. So from -3 to -1. What's directly between those? -2. So when you plug in -2, you're going to get a y value of -15. Okay, so when you go back to, you're going to go down 15. Here's my first one. Now, between the next set, it's going to go up above. So you're going to go from -1 to +1. That's going to give you 0. When you plug in 0, you're going to get back 9. So over 0, up 9. Looks like that. Then I'm going to curve back down again. So I'm going to have another minimum, and that's going to be between +1 and 3. So that's going to be at x equals 2. And your y value for that will be -15, which ends like that. Okay? So all you're really doing is you're finding more points to put on your graph.